Everybody, and welcome to this session on transformative change and how we can drive that with advanced analytics products from Microsoft. My name is Bill Jacobs. I'm a technical product marketing manager from Microsoft, although just recently. I joined Microsoft recently with the acquisition of Revolution Analytics, where I was field CTO and director of product marketing. So what we're going to talk about this morning is a kind of a survey of all of the advanced analytics products available to you from Microsoft. I'll be joined by Lance Olson, who is a partner director, actually kind of a product line manager, if you understand those titles, within Microsoft. He is involved very deeply in the Cortana Analytics product. And as I said, my heritage is in some of the R-based products that we are busily working on for you. We want to talk a little bit today about a couple of things. First, we want to talk about the general topic of advanced analytics and what's driving it. We want to talk a little bit about what some of our customers are experiencing with each of the various products. I want to do a few demos for you of both the R-based products and the Cortana-based products, and try and get all that done before the clock runs out and they give us the shepherd's crook. If we do that well, we'll end with a few minutes at the end for questions. Before we do that, I always like to know who I'm talking with. So let me ask a few questions. How many of you would consider yourselves data scientists, whether a statistician, actuary, risk analyst? Anybody here that actually practices that as their job, one or two? How many of you have teams in your organization that are doing that? Now, keep your hands up. Keep your hands up. How many of you know who those people are? A few of you put your hands down. That's good. That's changing. If I asked that question a year ago, half of you would have put your hands down. Because historically, data science and the folks that practice data science wouldn't have called themselves that, number one, probably. But number two, they would have worked independently of IT. There's a saying that prediction is especially hard if it's about the future, and that's Niels Bohr, a Nobel Prize laureate. It's his joke. The more practical quote that I think is driving some of what we're doing is from another fellow whose name I'll give you after the quote, and it goes something like this. Predicting rain is easy. Building arcs is hard. That's Warren Buffett. The reason that's pertinent is, as we saw the world evolve with data scientists largely being in a separate organization, separate from IT, and IT operating in a separate sphere, and the two not working together, it was very difficult to operationalize predictive analytics so that it was a day-to-day part of decision-making in organizations. That's changing. It's changing very rapidly. Some of the products will show you, help you address that. And that's why I asked the question, how many of you actually know where your data scientists are? Anybody nervous about the term data scientist? I am. I don't like it. One of our guys is from Revolution is a consultant, a deep 10-year experience in R and 10 years in SAS before that, and he says, I'm not a data scientist, I'm a statistician. He says, the reason I call myself a statistician is nobody who isn't a statistician calls themselves a statistician. So you can be pretty sure you're getting what you ask for if somebody goes a level deeper in the titles that drive data scientists and says, I'm an actuary, I'm a risk analyst, I'm a biostatistician, I'm a mathematician. These are the titles that have kind of grown up in the data science world. They are not the only titles, and what's very pertinent about what we'll show you later in the products is that it's very important to realize that we must expand the scope of the audiences that can employ data science and build predictive applications in order to advance the state of the art. And that drives a lot of Microsoft strategy. So let's get into it. Another funny quote, anybody ever heard the saying, history doesn't repeat itself, but it does rhyme? Who's heard that? Who said it? Very good. So I walked into a meeting one time with a CIO and I said, you know, I think I read that on the Motley Fool website. And he lowered his glasses. He was older than I am, which is hard to get. He looks at me and says, Sonny, that was Mark Twain. Well, the fact is, the transformation, the disruption that the arrival of big data, the compute capabilities of the cloud, and the evolved state of predictive analytics together represents such a disruption. We've only seen a couple of waves in the tech industry like it. I'm old enough to have seen about 4 or 5 major disruptions in tech. This is probably the most sweeping one I have experienced, probably since the days when we rolled customers off of mainframes onto Unix-based mini computers. And that was happening about the time I got out of college in the 80s. This is every bit as sweeping a change, and it is actually necessary to have all 3 of these components aligned in order to truly achieve the benefits. How many of you are running an EDW, an Enterprise Data Warehouse? How many of you are thrilled with the notion of figuring out how to eat a petabyte in your data warehouse? How many of you feel like you need to eat a petabyte to get something done? There's some of you here. There are many of you that probably don't know where that petabyte's going to come from, but that wave is just over the horizon and it's cresting. So if you are in a position of on-prem systems where you cannot conceive of storing a petabyte on-prem, you're probably going to have the cloud to deal with the big data. If you're historically a BI professional, how many of you are historically BI professionals? What tools are you using? Just shout it out. Power BI, Tableau, Click. Okay. If you're in those tool frameworks, how are you going to grapple with a petabyte of data or terabyte-sized files to do predictions off of? Some of those tools will handle it. A lot of them won't. The cube-based model of BI doesn't lend itself to predictive analytics. And so the third step here is the evolution of a range of products that suit your skills, have the capacity to deal with big data, and help you grapple with the split that on-prem and cloud together mean for your business. How many of you are going to do a lift and shift to the cloud? Everything's going to go to the cloud right now. How many of you are desperately seeking Susan, where Susan is the evolutionary approach that makes it tractable? Well, I think most people are looking for a path to the cloud that allows us to embrace those benefits. And so that's the challenge we face in advanced analytics. Microsoft entered the space, and I'll show you a little bit later a slide about how that happened, but a lot of what Microsoft has evolved began with Cortana, which was a collection of products to create an end-to-end solution that's centered around Azure machine learning. We recognized that we need to expand our capabilities, and this depiction kind of gives you an idea of the range of capabilities now available from Microsoft. And we'll basically, in this presentation, start from the right and move to the left. I'll cover the first couple of items. But looking right in the center, Microsoft assembled the Cortana Analytics Suite, or the Cortana Intelligence Suite as it is now known, to bring together the best of our products in the cloud for providing an end-to-end capability with one goal in mind. And we learned this the hard way through the evolution of Bing. And that was the key to data science, is experimentation at the speed of thought. We were experimenting a couple of experiments a quarter, and Bing was kind of lagging the other search engines. When the company recognized this and built a framework in which we could conduct hundreds of experiments at a time, suddenly market share in Bing almost tripled because we were able to improve the product that rapidly. How many of you have organizations that are set up specifically to experiment and fail quickly in projects like data science and predictive analytics? A few of you do. The best of the business, the best and brightest in this business, recognize that you're going to try 100 things and you're going to have 99 duds. And you don't know when the 100th one's going to come along. But we can go into this later, but there are big organizational challenges there for most companies, but that also represents a tools challenge. Cortana is built to enable you to ingest data, route data, track data, stream process data, deliver it to a repository, and immediately get into drag and drop analytics. And we'll show you some examples of that later. The reason that's important is, remember I said earlier that we need to broaden the focus, broaden the array of tools available so that different skill sets can engage in predictive analytics and make it part of their daily operations. Anybody heard the term citizen data scientist? Okay, well, it's an interesting term from its origin, but the point trying to be made is that we need to make these tools easy enough for business analysts to use without massive investments of learning to program in Scala or Java or Python or C++. And we're doing that. That's what Cortana does. Meanwhile, off in another space called the open source world, a language was evolving that had its roots in a language called S, commercial language invented at AT&T in about 1990. A couple of guys in New Zealand said, gee, we like the language, we hate the price, AT&T. We'll write a copy of it in open source. It's not a copy, but it's damn close. That language was called R. It hit the mainstream about 2000 and now enjoys a user base of about 3 million people. What's important is that while we're busily trying to build tools for the citizen data scientist, for the line of business guy, the MBA who just gets out of college and wants to try and predict the behavior of a product line or of customers, of disease, the R-based world is one that is set out to serve statistical analysts in fields like sociology and medicine. And so there's an entirely separate thread of users with a separate thread of skills. Microsoft is broadening the array of products to ensure that more people can participate in predictive analytics easily. Lance will tell you some about the things we're doing in our analytic APIs. We call these the cognitive interfaces, and some of the very cool stuff about dealing with humans from the computer side is all existent in this world. And what's unique about it is typically these buyers, these users, are app developers. They don't want to do machine learning. They want to call a machine learning routine that's already trained and knows how to spot angry faces in a crowd, to give an example. And finally, we're working in the direction of solutions. And so Microsoft is going from a single offer, essentially, with the Cortana Analytics Suite and its underpinning Azure Machine Learning, to a very broad array of products that range from your citizen data scientist all the way to your hardcore econometric modeling guy in the World Bank. And at Revolution, we actually sold to those guys, the Federal Reserve Bank, et cetera. And so what I would leave you with at the high-level summary is Microsoft is very motivated to produce the kinds of products that many different kinds of people need to engage in advanced analytics and bring this predictive capability into organizations. We build products that will scale to massive scale. The R products that we built at Revolution Analytics can be directly deployed into very large Spark clusters. They are now included in HD Insight Premium Edition. And so it's quite practical to build up a fact table of 3, 4, 5 terabytes of data and feed that single file to a Spark cluster running 100 nodes, and with a single line command say, build me a decision tree that picks the best way to classify new events that I would normally add to that tree. The agility component of the product line is the one that is most important for the citizen data scientists because they are typically the ones most charged with very rapid experimentation. And finally, the ability to deliver this to you at costs well below the historic norms in the industry. Do we have any SaaS or SPSS users in the crowd? I see a couple of hands. These are legacy products that are on-prem and are frightening every year for the CIO to look at the renewal bills. And so the third major piece of our ability in advanced analytics comes with delivering products that can do advanced analytics without the price tags that have been associated with analytics in the past. The second and most important thing, this slide says work with what you have and it talks about technology. True. I would argue this is really more about the skills and talent that you have. Anybody ever try and get an Oracle DBA to learn SQL Server? Or a SQL Server DBA to learn Oracle? Try and get an R user to learn Python. Not going to happen. People work best in the things they know. The greatest challenge CIOs have today in deciding how to approach advanced analytics is the talent problem. Where do you get them? There are articles out there now, why so many fake data scientists? That's a direct quote of a title, an article that's appeared several times. There's so many people who figured out this is a gold mine of a place to claim to have skills because everybody's so desperately looking for people who understand how to build predictive analytics. By adapting our products to the various skill sets that exist in the market, the business guy who wants to draw a picture and experiment with different versions of that picture looking for a prediction that works, to the biostatistician who's picking apart genetic data, looking for the markers in that data that relate to certain causes of disease. They have very different skills. We have products that match to those skills so that the product doesn't become the impediment to the innovation. And finally, we are working very, very hard, and Lance will show you some very cool stuff that we're doing in advanced and artificial intelligence, bringing machine learning and deep learning to bear on very difficult problems like language, like face recognition, emotion detection, image analysis, and eventually video analysis, lots and lots of very big challenges. What's very cool about Microsoft is that there is much investment going on. You see here the HoloLens and some of the other products. Bing, Skype, and Xbox and Office 365 are all machine learning-based products. And so Microsoft is not new to this game. Microsoft's $12 billion R&D investment annually has a huge component that is funding machine learning and data science investments. And we're bringing what we learn, that rapid experimentation framework that fed into the knowledge about the Cortana Intelligence Suite, that came from other investments. And this will continue. We will continue to leverage Microsoft's massive investments. A new thing for Microsoft, how many of you think of Microsoft as an open source company? Well, I joined the company a year and a half ago when I got acquired. I'm like, oh no, here we are in a commercial company. Nope. Go look in Azure. Go look where the workloads are in Azure that we're seeing. Heavy emphasis towards open source. Revolution Analytics that I worked for a couple of years, what was acquired a year and a half ago, an open source company. We ship Python, an open source language. And so the company is making major investments both in engineering talent but also in the legal structures. We have to be careful as a company. All companies do when you start to dance with open source. But the value to you, an end user, is huge, and so we're trying desperately to deliver that value. We're very busy in publications. I think probably the most important part is the shift towards the trust of Microsoft and our ability to build products, deliver them, and sustain them. We're all, of course, keenly aware of Amazon, Google, Yahoo, and other companies. How many of us think of them as an enterprise solutions company? Do they have the support structures that you're used to and you know how to work with? This is what Gartner's trying to tell us, is that Microsoft provides a very wide range of products, but also a long history in providing enterprise solutions to back them up. And so with that summary, I'm going to do a quick demo of our R-based products, and I'll turn the podium over to Lance to talk about the Cortana suite and some of the advanced and the bots and cognitive APIs that are part of the product. And so what I'm going to show you first, and I'm going to abbreviate the demo a little bit, and the deep dark secret is I think I have something not quite working like it should. Let's set up the example. Let's type the password in correctly first, and then switch the monitor over to it. Okay, we're not getting there. I got by the caps lock monster. There we go, okay. And we are on 8. So what we're looking at here is a Windows server stood up in Azure with a copy of SQL Server in it. The Microsoft R products began life as the R interpreter, plus a bunch of enhancements that were created by Revolution Analytics to give the R language the ability to scale massively, to parallelize work across many nodes of, say, a large EDW or a Hadoop cluster, and to invoke that work remotely. When we first visited with Microsoft 3 years ago, we looked at SQL Server and said, perfect place to land this technology. And so our first goal in creating R-based products in Microsoft was to enable the ability for someone sitting at a workstation, which I'm going to demonstrate to you, to actually do work in the SQL Server database by pushing work into the database with what we call remote execution capability. R is a local language. It was designed to run on workstations. But the problems we're trying to solve are of a scale that workstations are no longer appropriate. So let's go to the customer side of this. How many of you get people hitting you up with advertising information via your text messages and your email and, oh, come click on my website? You know how much value there is to a marketing organization if they can figure out what makes you likely to say yes and take that message and click on the page? One of the biggest applications on the internet today is the brokering technology that puts an ad up in the upper right of your Bing search page or something, and then when you click on it, it directs you to the ad. That brokering is one of the highest volume apps on the internet. It's a huge problem for businesses. How do we maximize the productivity of our marketing activities, whether it's outreach via text or email? How many of you work in that business? Anybody marketing automation folks? A couple. There's probably 300 companies that ply that space, maybe, from the from the core metrics guys all the way down to very small shops. In this particular case, what we wanted to do was let's take some ad response data, take a look at how people are responding, and try and figure out demographically who responds to what kind of ads. Well, I guess we won't use the mouse today. So to do something like that in SQL Server, let's take it for granted that I have SQL Server up and running, and that SQL Server has an option I can install, which I have, and that option is the SQL Server R services. How many of you are familiar with R services? A good number of you. Okay, so what this is the capability to run both R and the massively parallel R algorithms that we produced at Revolution inside the SQL database. Moreover, we can run them as an R user, or we can run them as a SQL user, and even fork stuff from PowerShell. I'm going to show you R just because I have that loaded up. But if you take a look here, in our example, the first thing, of course, we're always going to need to do is create a little bit of data that we can do some modeling on. In this case, it's 3,000 or 4,000 rows. But in the R language, the typical model for doing that is to get the data loaded in the database. Historically, R users have done the load themselves, and this example actually loads in R. The reality is that most people these days will say, gee, if I'm paying an extra $20,000 a year for R programmers, why in the heck have I got them doing data manipulation? So one of the most powerful reasons for putting R analytics inside a database is you do analytics fast. By just a hair, the second most important reason is you can utilize SQL-based talent that you already have in the organization to unload that very trying phase of loading data and manipulating data prior to doing predictive models. How many of you have heard 80% of the work in data warehousing is in loading the data? Guess what? And it's still a problem. And it's a problem in predictive analytics as well. So if we can move that stuff into the database where database engineers can manage it, we can raise the productivity of our programmers by a very large amount. So in this particular example, I'm going to ingest a bunch of data, and I'm not going to actually run these because they run a little tediously long when we start running big models. But to get to anything with R in the database, I only do a couple of simple steps. Take a look. First, I define a connection string, and the parameters are in R format there, but you're going to recognize the same thing you would do in another application. I'm going to identify the database, its location. I'm going to identify where I'm going to run it. I'm going to put that into an algorithm called RX and SQL Server, which basically says to the engine, anytime you hit a request for a massively parallel algorithm, push it to the database instead of running it locally. It's called a remote compute context. It's something we added to R. Once I add that, I can now load data and act on that data. Here's an example. I'm going to pull data and act on it in the database called Market Touchdown, and these are the successful outreaches to clients. And so I load that table, specify a library, a data manipulation library called library data. These are all very standard R functions. Identify the data I care about, and then I'm going to go ahead in this script and do a little bit of data manipulation because each algorithm in data science requires different types of inputs. Some requires Boolean, some requires linear variables and that sort of thing. So this is the very typical phase that follows data loading called feature engineering. Once we complete the feature engineering and we have the features of the data set in the form that we want them, we can then go to the all interesting and fun part of creating predictive models. Now, how do you create a predictive model? What is a predictive model? How many of you know enough about predictive analytics to give me a definition of a model? Who can give me a definition of a model? I know C. Young can. He's my ringer. It's just an equation. The goal here is to create simple equations, either decision trees or linear equations that, when fed a series of inputs, have a tendency to provide an accurate prediction of some particular dependent variable. A customer's proclivity to click on a link is the example we're using here. And so there are many different techniques, decision trees, classifiers, linear regressions, logistic regressions, something called a random forest, which is a way to run 100 different decision trees randomly seeded and see which one works the best. They're all very standard algorithms understood in data science. They run typically from 1 or 2 line commands. In this example you see here, I'm going to get some information out of the database. I'm going to do a little bit of manipulation on the data and then run this command. Where is it? It's in here somewhere. That actually creates a random forest model. I'm going to set the compute context to be the database, or locally. I've actually, this example, I pulled data into my local context, and then I predict, I take the model I've built, and I run this thing called RX predict, and this is essentially what we call scoring the model. I don't know why we don't say scoring the data, because you're actually scoring the data, not the model, but we say scoring the model. So the basic flow is load data, which I didn't show you. We assume that the DBAs have done that for us. Feature engineer the data to put it in the formats we need using R commands, because that's typically the guy who's going to understand that, guy or gal. Then run the models, then evaluate the models, and here I'll score data and then go back and look with what's called an area under the curve. It's how much improvement is this model making in the outcome that I'm looking for. And then most importantly, use RX predict to score a bunch of the data. Once I've scored the data, it sits in the database, and very simply, I can then pull it in Power BI. What's kind of interesting about Power BI, and I don't have it running correctly here, so I'm not going to do much with Power BI, but the Microsoft R products provide a typical IDE-based experience for an R programmer. A lot of our programmers are very comfortable with Linux workstations and R because they're open source guys, and we support both the Microsoft Visual Studio with R tools installed, or the RStudio third-party product to allow people to do the development. Once they create the feature engineering, then run the models, create those predictions, the predictive model can be ported about. Why do I say that's important? Remember I talked about how would you grapple with a petabyte of data in a SQL Server or a Teradata environment on-prem? You probably wouldn't. This is one of the few products that will allow you to push data up into the cloud, build your models in the cloud, where you can use HD Insight on an as-needed basis, take those models, install them in the database, and score data either in batch or in individual events and produce results. These particular results that are not actually running right now, but if I'm running these, you'll actually see that I'm pulling in the scored leads from the database and using those depictions to inform this dashboard that my campaign manager then uses to decide, based on demographic, age, location, whatever parameters the model thought were most important, to predict the response of that particular user population to the ads I'm going to send them. This is a very simple departmental example. Now, let's look at some other customers and what they might be doing with the product, and I'll skip past the demos in interest of time. Okay, I'll find it. It's eventually here. There we go. So we'll skip past the demo a little bit. We can run much more involved demos at the booth if you like. To summarize the, I got a black screen here. Why is that? Wrong button, that's why. So what I want to talk a little bit about is what some of our customers are doing. And I'm going to skip to a slide. I think we took out the slide on the R-based clients. But to give you an idea of the types of problems people are applying our technology to, several of the major credit card issuers utilize Microsoft R products. The most rapid payback, large value application for them is combining massive amounts of demographic data, household data, credit data, home value data, automobile purchase data, and from that creating predictive models that will help those credit card companies determine who is a good risk for issuing a credit card. How many of you have seen the Progressive ad where they plug the dongle in the car and guys peek up over the fence from the competing insurance company? What they're doing there in that application is called usage-based insurance, and we have several companies that utilize Microsoft R there. So that's one that we probably all see day to day. Flo sends us the dongle goes in the car, our driving habits get loaded on the dongle, we pop the dongle back in the post to Progressive, and they come back and say, Bill, you're a terrible driver. We're going to really rate your insurance way up. But that's a massive data challenge because the combination of data sources that are being used by companies like USA and American Family is not just the driving data. Driving, credit, age, education, family status, type of car, other cars owned, kids in the household. You can imagine the list of pieces of data that an insurance company would use to do usage-based insurance. And so they wind up with these terabyte-wide, terabyte-size files that they need to do massively parallel computation on to build those predictive models. And then some business guy says, hey, I'm going to put that model in my rating application. And we could go on and on and on. There are some bad guys in the world. I think some of you probably watched the debate last night. One of the topics is, of course, how do we detect terrorist events before they happen? We don't know exactly what's going on with R in certain secret locations around Washington, D.C., but we know that it's a major factor in the systems that they use for looking for anomalies in communication patterns. And those same types of technologies are bleeding out into security event identification and monitoring solutions, SIEM, at companies that are building intrusion detection systems. So with that, I won't go into great detail on any more customers because we're kind of short of time. But there are many, many applications of R-based technologies across the world. I thought this slide was out, but it is in. And so you see here the breadth of vertical industries that are using R as one of the tools in their arsenal for creating predictive analytics they can apply around the industry. I'll leave you with this as a final thought. It'd be nice if the world only needed one product and one technology, but that's not true. There are users who will not program in R, and there are Python guys who think R is awful, and R guys who think Python is awful, and business people who think programming is a pain in the butt. And I tend to agree with all of them. Again, predictive analytics is about achieving business results, not about having fun with programming. And so by applying a series of technologies to the market, Cortana for users who want rapid experimentation. R for people who speak R already. Python for people who speak Python already will best adapt to the needs of the customers and allow each person to have the tool set that they need. R is on a tear. I was shocked to see it grow to number 6 2 years ago, and I was surprised even this year when it jumped even higher in the Spectrum ranking of computer languages. So we'll stop the talk about R at this point. Suffice it to say, Microsoft is wholly invested in R-based products, and we will use R in other parts of our product line besides SQL Server and HD Insight as time goes forward. And with that, I'm going to turn it over to my colleague Lance, who is going to take it from here, talk a little bit about some of the work we're doing in more advanced analytics and artificial intelligence.
Great, thanks, Bill.
Sure.
All right, I'm just going to make sure I can switch on this other guy. So I want to do a few things with you here. I want to walk through, I guess I should back up. For starters, so my name is Lance Olson. I run the program management team for Cortana Intelligence Suite at Microsoft in the product group. And what I want to do is spend the rest of the time really covering a few key things with you. I want to walk through some customer cases, and we'll look at the architectures that we use in the deployments that we have. Look at some real-world examples, and then also talk about our roadmap and the key areas that we're investing in. So I'm going to start by going into, this is a progression that we see that's driving a lot of the changes in the systems that we deal with and in the kinds of insight that our customers try to get. So it's really an evolution from what we would think of as descriptive or diagnostic, which is really, that's loading data into a warehouse. It's creating BI visualizations on top to know how many widgets did I sell every week in every region to every type of customer. It's looking backwards, really, at how did the business do. But more and more, what we see is a desire and a need, actually, in our businesses to be able to predict what's it going to be like next week, what's going to be like next month, and then also prescribe, if I did the following, if I took the following action now, how can that change the outcome? And what is the outcome likely to be if I make those changes? One of the fundamental impacts of that shift is that the underlying systems that we use need to change. The constraints and the requirements of those systems change. So in the descriptive world, if you're thinking about a database architecture, we think really hard about the questions we want to be able to answer. And if we know what questions we want to answer, we can design, we all can design great schemas, and we can put indexes in there, and we can make a really fast system that can give you a great response for getting answers to those questions. The problem is when you move to the right on the spectrum, you don't know what questions you want to ask going in, so you can't actually build the indexes. You can't actually optimize the schema. And that's why we see in these scale-out systems and things like Hadoop, we see this notion of schema on read. And we also see people using more and more the brute force approach that you get with scale-out and large in-memory systems like Spark to basically compensate for the fact that we didn't have a highly optimized index. Now, we're working to add dynamic indexing to those systems as well. But that's really part of what's driving the evolution of these systems. Now that's causing a whole new set of tools and a whole new set of patterns. So I wanted to look at some of the types of changes that we're getting as we apply these patterns. So this is an example of a company called QuarterSpot. QuarterSpot specializes in small business loans, which has ever since around 2008, 2009 became a very tough market. And what we did is we worked with them to connect all of the various variables that impact loan defaults into their system and build a model that predicts loan defaults. The most interesting thing to me, at least about this case study, is the results. So what we were able to do is cut their loan defaults in half, grow their business by 15%, cut their overall cost by 85%. So think about that for your business. What if your CEO came in and said, I want you to cut your failure rate in half. I want you to increase the business by 15% in the next year, and I want you to cut your cost by 85%. That's kind of crazy. It's transformational in terms of the types of changes that we're talking about. And it's not uncommon that we see this. I want to go to another example. So this is Schneider Electric. So Schneider is a very different scale of customer as QuarterSpot. Schneider is one of the largest energy management companies in the world. They're in over 100 companies, and they have over 100,000 employees. And they do all kinds of predictive energy. So what we worked on with them was actually a predictive maintenance scenario where they have large solar arrays in third world countries that they service. And these provide reliable sources of power to remote towns and villages. Well, one of the problems they were having is they might have a dust storm come through. They might have an animal come through or a person come through and break part of their equipment. But they might also have a dust storm come through and just drop a bunch of dust on top of the equipment. Either way, what they see on the other side is a reduction in the power throughput of the solar array. It turns out, though, that there's a huge cost difference between sending somebody out to the array with a squeegee versus sending somebody out to the array with a whole different set of hardware that they have to go replace the thing. And so what we did is work with them to predict so they actually can tell exactly what caused the failure, and then they can provide a more reliable source of energy. So I want to show a quick video that will highlight what they do.
Today, about 1.2 billion people in the world live without electricity. Another billion have unreliable power, and 2.8 billion people use coal, wood, charcoal, or animal waste for cooking and cleaning. Energy is critical for economic development and for powering basic social services like healthcare and education. Today, Schneider Electric is transforming the lives of millions of people in Nigeria by partnering with Microsoft and the Lagos State Electricity Board to provide sustainable solar power to over 200 schools and clinics. Schneider's Connext Insight uses Azure IoT Suite to connect intelligent devices to the cloud, enabling remote monitoring, diagnostics, and real-time tracking of energy usage patterns. With Cortana Intelligence, workers can spot repetitive trends or declining performance and initiate preventive maintenance to ensure a continuous power supply. For the first time, technology in the classroom is accessible. Students are able to charge devices and personal nightlights for at-home study so learning can continue into the evening. And science and computer labs that used to sit idle now operate full-time during the school day, empowering students with new educational opportunities. Clinics no longer rely on limited diesel fuel resources to run dilapidated generators. Instead, care is accessible 24 hours a day. Reliable electricity powers lights for nighttime surgery. Pumps supply fresh water to improve hygiene. And refrigeration preserves much-needed medicines and vaccines. By 2020, an estimated 190,000 students will benefit from improved access to educational tools. And 4.7 million patients will receive better health care. With the Internet of Things and cloud-connected energy solutions, reliable access to power is no longer a dream. Today, Microsoft and Schneider Electric are empowering life-changing solutions worldwide and enlightening the future for millions.
All right, so does that guy have a voice made for radio or what? No, so what we are, this is it's a great example of the kinds of transformational change we're seeing. And so this is just a quick, I'll give you a quick view of the application that we created with them. And this is a dashboard view of the app. I'm going to just drill in and click on a particular view here. So this is what a solar array would look like to the ops center at Schneider. And so you can see various meters that show you, as events come in, show you what the infrastructure health looks like, what the battery temperature is. You can see some alerts. And if I click on the alert, you can see the current solar power that's being generated, but then this area in the gray is the predicted area. And you can see that it's going, the actual versus the expected is going down. You can see there's also an issue here where you have a temperature warning increase on a battery. And now, because I'm using the Azure IoT suite as well, I can also deploy, if I need to, I can deploy firmware updates to the devices, to the hardware. So I can basically see what's happening on the devices themselves. I can see the trends. I can use those trends and the way that the failure happened to actually predict a difference between, oh, it's just dust on the screen, because then if it's dust, it's going to be a more gradual window, versus if it's an actual hardware failure, it's probably going to happen more quickly. So I can actually figure things out like that based on the changes over time. I'm going to keep going because we have a lot of other examples to go through today. So the next one I want to talk about, now you've probably heard, we've talked about Rolls-Royce a few times, I think, here this week. And so I want to I'll drill in and do a particular focus with Rolls-Royce. But one of the things that we worked on with Rolls-Royce is actually really interesting. This makes sense to me, but I didn't realize it. First of all, I went to meet with these guys last fall in London. I was all excited because I thought, meeting with Rolls-Royce in London, they're going to pull up in some really cool car, right? But it turns out they specialize in engines and airplane engines. They actually do a lot more on airplane engines than they do on cars. They don't actually sell airplane engines, though. What they sell is airplane engine time. They sell the running engine. And that way, if the airlines has an engine that's offline, it's not the airline's cost, it's Rolls-Royce's cost. And so that aligns their customers' benefits with their business model. And so what they want to make sure of is they want to make sure, of course, that the engines are always healthy, that the flights are always going to be safe, but then beyond that, they want to make sure that the engines are always available, that there's never a moment where that engine could run and yet it doesn't because it's not ready, because it's being serviced. So they're constantly wanting to ensure that these things are always healthy and reliable and ready to go. So what they do is we worked with them to connect two different kinds of data flows up into the system. One is real-time data coming through the satellite connection on the plane, coming off of the engines itself, and it's looking at the critical pieces of information that they need in order to make decisions about the safety of the engine itself. And they may have a case where they actually can, if needed, they can tell the pilot, you need to land or you need to fly or descend in a different way because we don't like something we're seeing on the engine. It also generates, they capture a lot of data on the plane. On a long flight, they might capture a terabyte of data. And then when the plane actually lands and pulls into the terminal and gets within Wi-Fi range, they transfer the rest of that data. They use that to predict the efficiency of the flight and the flying habits of the pilot. It turns out there's a trade-off between, for example, when you're landing, the most efficient, fuel-efficient way to land a plane is to come down and kind of smack on the runway. It turns out that's the least fun way to land in the plane as a passenger. So they kind of have this fun, comfort versus fuel efficiency trade-off. What we would like is to see the plane come in and just kind of hover over the runway for quite a while and then touch down so softly that we don't even know it landed, right? So what they're doing is they're always looking to find where's that sweet spot where the ride is comfortable and we deliver the experience our customers want, but we don't spend too much fuel. In a business where you spend billions of dollars a year on fuel, even a percentage optimization on fuel can save you a lot of money. I'm going to skip through their video just in the interest of time, and I'm going to show you, I'm going to talk to you about the architecture that we use. So this is an example architecture based on what we've done. These are the data flows based on what we've done with Rolls-Royce and other customers. So on the left side, we have basically all kinds of data coming in that is relevant to their flight predictions. So it might be the flight plans, it might be the maintenance data, might be the weather, It might be data coming in off of applications that are used by the employees, the pilots, and the flight attendants. It might be servicing information. All of this comes in various forms. It comes in events. It comes in queries off of a relational store. It can come in as batch files that get moved across the system. And while I'm talking about airplanes in this case, this pattern is common to a large number of these predictive scenarios. Like Bill said, 80% of it's about getting the data in and getting the data ready. What they then do is they land the data, they ingest the data into a store, and they process it. So they'll clean it, they'll aggregate it, they'll do joins. They might run models that add additional columns to the data, that add predictive elements to it. Then they put the data into storage. They tend to do it in a few different ways. They have raw storage because they may want to go back and do things they didn't realize, ask questions they didn't realize up front. They have some data that's been enriched in that ingestion process, and then they have some of that data that they've also published out for other people across the organization to use. That data then gets used in a couple different ways. It gets surfaced up to their operations people, to their pilots, to their field teams, their marketing and their sales, through dashboards and applications and reports. It also gets accessed by their data scientists and their data analysts. And they spin up different types of analytic engines to connect to the data and run ad hoc experiments and create new models or refine the existing models. And then all of this data is governed, secured, and monitored by a set of overarching services. So if I now take, that was the data flow view, this is the service view of the same thing. So here are the services that they use to do this. So we use Azure Data Factory, for example, to bring the data in off of the engines and off of the planes and put it into the system. We use HD Insight and Azure Data Lake Analytics to then do the scale-out processing of the data. Then we landed into the data warehouse. We also landed into either blob storage or Azure Data Lake Store. We use Power BI and app services to build web apps and mobile apps and Power BI dashboards to interact with the insights. We use Azure Machine Learning and R and Cortana Intelligence Suite to process the data. And then we also use Spark to do analytics over the data. All of that data is governed through the data catalog. So when they publish to the catalog, and that's how people can find the assets. So if the ops or marketing or sales want to use it, or if the developers, when they're building the dashboards or building the applications, they can discover it and get governance through the catalog. They use Active Directory to secure it. They also use a few other things I don't have in there, like Azure Key Vault to do encryption of the data, and then Op and App Insights in order to monitor the application or monitor the system. So I guess the reason I highlight this one is it's a very common pattern. You could do the same thing if you were predicting retail sales. If you're predicting the number of customers that are going to buy in each region, you would have a very similar model. Basically, take all the data you think is going to be relevant to getting that answer. It's going to come in all kinds of different shapes and sizes. Land that into the scale-out engines. Use that to clean it up in bulk. Then you can decide, typically, you can take the raw data and just keep it in something like Azure Data Lake Store or blob storage, and then have different tiers of more enhanced data that you publish and use. That allows you to always go back, and if there's a question that you realize later or a correlation that you didn't see up front, you can go back and rerun the queries and ask new questions. It also allows you to have a pipeline that's operationalized, that's going to your business users, your operations and sales and marketing, but also have a way for your analysts and your data scientists to continue to run experiments and make the models better and better. All right, so now I'm going to switch to product updates and the roadmap. Who here has seen this slide? You guys seen this? Okay, that's good. So about maybe 30%. So I'll just cover it briefly. These are the services that make up Cortana Intelligence. So like I talked about in the last example, there's information management services, there's services dedicated to data storage, there are services dedicated to analytics, and also intelligence and dashboarding and visualization. So those are the core areas I'll talk about. And these all come together. It's funny, the thing that we typically are trying to get out is that insight. It's kind of like that bottom right-hand square, the dashboards and the visualization and the apps. That's the end result. That's where we get the action that we can take. And then everything else is really the means to that end. It's processing the data, governing it, ingesting it, all of that so that we can get a clean signal that has all the variables, the inputs that are going to drive the insight that we want. And that's really, when we think about Cortana Intelligence, it's the set of services that we have in Azure for taking data and then transforming it into action. So if I talk about the roadmap, we'll talk about R, and then we'll also talk about Cortana Intelligence. So for R, there are really 4 core areas of investment we're focused on. The first one is making R available everywhere. And you'll see we talked a little bit about having R in SQL and R in HD Insight, and then R on premises in standalone. And we're doing more in that space to make R available everywhere. And we want this in general for the analytics engines, the predictive technologies, is to make them available so that you can run them on premises, you can run them in the cloud, you can put them into a Docker container and put them on a device if you want, or run them on an edge and a gateway. Or you can train, if you want to train a model to recognize lanes on the freeway and run that in a car offline, you can do that. We don't want the car to have to be connected because we don't want you to lose the lanes when you go into a tunnel. Probably not a good thing, right? So we want that local ability to run, really ability to run anywhere. We continue to focus on one of our core value props around enterprise-grade performance. And if you saw in Joseph Sorosh, his keynote yesterday, he showed an example of really world-class results we're able to get in scoring models inside of SQL, and we have a number of other investments that will continue that. AI-driven, so we are focusing on a number of new scenarios. We have integration with tools like H2O and OSS, other OSS tools, but also we have a new set of investments that we make that come from things like Bing and other innovation we have in the company around our computational network toolkit. And then finally, solutions focus, which is really a set of investments we have to make it so that you have well-known patterns that you can use and go deploy and have a starter that basically accelerates your time to solution. I'm actually going to talk through the Cortana Intelligence roadmap examples in depth in the following slides. So this will be a summary, and I'm going to, this slide deck is shared so you can all have access to it so that you'll have the summary you can access. But I want to dive in on some of these. So connectivity is a common question that we get, and it's a continued investment that we're making. So it's expanding data source connectivity, and we have over 25 different connectors already that we've built into the platform, into Azure, to bring data in. But we're continuing to add new connectors every month. We're also doing work to support open source file formats like Parquet. And then the last two on this first area are about simplifying the ability to get data in. So we're adding visual data movement experiences, visual authoring, and visual monitoring for Azure Data Factory. Today you can do that with, you configure your Data Factory with JSON objects. And what we want to do is make that a lot easier for people who can just do it with a visual designer. So that's coming in the next 6 months. Then we also are adding additional language and runtime support. So Spark, so that we can automatically spin up Spark clusters just like we do with HD Insight, and Azure ML integration. Who here has heard of Azure Data Lake or Azure Data Lake Store? Okay, great. So about half or more. So this is actually, Azure Data Lake came out of a project that we run inside of Microsoft. So we also are the IT group for a chunk of the data processing infrastructure at Microsoft. We have a large-scale system that we run that actually powers Windows, Xbox Live, Bing, Office 365, basically runs all of our properties. This is a system that we've been working on for about a decade. It is a multi-exabyte system. So we process, we have hundreds of thousands of nodes that we use inside of these clusters to run our data processing. And what we've been doing over the last few years is actually taking that technology and packaging it up in a way that anybody can use it. So that's what is really behind the Azure Data Lake. In doing that, we split it into two pieces. We created the Azure Data Lake Store and the Azure Data Lake Analytics layer. So there's basically a storage layer and a compute layer. We built the store with HDFS support so that we could take any open source package and run it on top of the store natively. We also built the analytics layer with open source integration. So we swapped out our resource management layer for Yarn and implemented Yarn inside of the analytics layer. So we can take Spark and Hive and other analytics workloads and run them as a job service inside the analytics layer. That way you can choose if you want full control over a cluster, you can spin that up and run it with HD Insight, or you can run it on IaaS, and you can point at Azure Data Lake Store. Or if you just want to have the easiest way to run jobs, you can submit the queries themselves to Azure Data Lake Analytics, and then we'll run those for you, and you just pay for the job time that you use. So that's really a core focus that we have, and these are two major services that we have that are going to be coming to market in the next few months in this calendar year. So that's a big emphasis for us, and we're excited because it's going to bring a massive scale to our customers. All right, so now we get into some of the cognitive pieces. And you've seen a number of these. I won't talk about every one. I'll just hit a few highlights. So these are the technologies that we've been taking. If you think back to that spectrum that Bill showed in the beginning, he talked about how we have R, and we have Azure Machine Learning, and we have cognitive services. The way to think of that is basically the easiest from a machine learning or an AI perspective, the easiest thing we could do is, well, make an application that does exactly what you want. But the reality is we won't be able to do that for every need that every case comes up. Even working together with you all, we won't do that all on our own. So the next easiest thing is if we have a model that's already built. That way you don't need a data scientist to build a model. You can use a trained model, and you can even take that model and add your own data to it to train it more for your needs. That's what cognitive services is. So this is kind of where I would start. If you were trying to build an analytics solution that you needed to do data science and needed to do some forecasting, I would start by looking at cognitive services and say, is there a model already built that I can use? Because if there is, then I don't have to build one. So these are models that we've trained using the data that we've built actually in that same system, the same store that powers Azure Data Lake. So for example, our vision, our computer vision APIs, is based off of billions of images that we've trained using Bing. And our knowledge graph and our language and speech semantics are the same thing. They come from very large databases that we've built from ingesting the whole internet and trying to create semantic meaning and semantic ontologies from that information. So an example is the knowledge service. This will tell you things like the meaning of a word based on how it's used in a sentence. So if a word says times, is it New York Times? Is it I've seen this 10 times? Is it times are changing? What's the actual meaning of the word? If you don't have a lot of data or a trained model, it's pretty difficult to sit down and write a program that's going to understand that and actually tell you what's the meaning of this word, especially if you want to do that across a whole bunch of different languages. So what we do is we use the models we've built. In Bing, we spent years trying to understand people's intent as they type in searches. And now those services are available to you, so you can feed a sentence to the API, and the API will come back and say, this is the meaning of each word in that sentence based on the context that you gave me. And here's the level of confidence I have in whether or not that's the actual meaning. So those are the kinds of things we do in cognitive. Now, I want to show, let's see. All right, let's do bots, and then we'll talk about, I'll show you guys an example. So you've probably all seen this. I'm not going to spend a lot of time on this one. This is what we're trying to do fundamentally with bots is map services to a conversational style interface. So this was a project we did at Build with Domino's. It's a pizza bot. So this guy logs in, he says, hey, pizza bot. And the bot authenticates him and says, hi, Jeremy, do you want the usual? No thanks, I'd like to try something new. We do language processing on that response. No thanks, I'd like to try something new. So that maps to an API call on the back end and says, oh, he wants to see what's new on the menu. So the response is, we've added 3 new items, Hawaiian barbecue chicken in the works, 3 options. He comes back and says, option 3, please. Shall I send it to your home? Because he's authenticated, so he knows the system knows who it's talking to. It knows what his address is. Well, that's a commercial example of the bot framework. Let me show a couple business examples, or non-consumer. So these are some other examples we've been playing with inside of Microsoft. This one is the age-old task of time reporting, right? What I do before we have a bot like this, what I do is I go to a website, or you load up some kind of app that is your company's internal app or internal page, and you say, all right, I'm going to report time, and then you have to go through that and find the app. First of all, it's probably the hardest thing. With a company bot, you just open up your phone and you send a text to the company bot. And you say, I want to report time off. It says, great, what kind of time off do you want to report? Vacation, sick time, or other. I pick vacation. It says, okay, vacation time, tell me what days you want to report. It brings up a date picker. I pick the date, and I'm done. I'm already authenticated, so it knows who I am. And I didn't have to install an app, and I didn't have to go to a web page. And especially if you have a company that you're targeting millennials, this is the most natural interface for them. The next thing I'm going to show is actually, this is a real bot that's deployed. These are screenshots off of my phone. Internally, we have a bot for Active Directory. And so that if I'm not in a place where I have access to AD and I want to just do a lookup, I can do that. So this is a conversation I took screenshots of. So first, and I'll read it because I know it's kind of hard to read in the back there. So it says, who is Lanso? That's my alias. So it says Lanso is a director of program management in the following division. Where's his office? Now it knows who, if I say him or his, it knows who I'm talking about because it's contextual. It's in a conversation, just like a human would know the context. It says, here's his office number. What's his phone number? It lists his phone number. Who's his manager? Lance reports to Joseph. Now, here's where I confused it. I said, who's on his team? And it says, sorry, I don't know anyone by that name. Maybe you were trying to say something like, what is his office number? So it kind of got thrown for a loop. And so I had to rephrase. I said, well, actually, who works for him? But now, because I've talked about Lance and I've talked about Joseph, it knows that there are two actors in the context now. So it's not sure who I'm talking about. So it says, do you mean Lance or Joseph? Pick a person by typing the number corresponding to that person. I type number 1, and then it says Lance Olson has 11 direct reports, and then lists them out. So that's really, the reason I share this is to show you what that conversational style looks like and how that's different from an API, how it's different from calling one of your services. You can basically build, there's really two core differences. One is you can build a contextual experience. The other is that it's conversational, the conversational style. Now in this case, it's text, and I can just use it with my phone, or I can use it with Skype, or with Slack, or whatever textual chat you want. More and more, though, I expect that this will also move to spoken conversation. So you can think of this as, I actually think of this as a new application type. If you think about the last application type that we saw was mobile applications. Before that, it was web applications. Before that, it was rich client applications. That's the last 30 years worth of applications, fundamentally, from a consumer, from a user interface perspective. This looks like a new application type. So we only see one of these about every decade. So it's pretty exciting. We think that that'll go across all typed and also spoken mediums. And so we're working really hard to connect all the services behind that so that you can have nice experiences on the front end, but then power them with all of those systems that I talked about on the back end. But that really makes language understanding and speech and context all of a sudden move really high up on the priority list for us. Because if you can't understand the user's intent from the language, then you can't really build this kind of experience. So that's where we're headed in bots and in cognitive. And I want to show now another example in cognitive. You've probably seen, who here has seen the How Old website? Quite a few, right? So I'm not going to spend a lot of time on it because I knew you'd seen it, but I want to show you something that we're doing on top of it. So first of all, I'm going to just show you a picture. This is my daughter, Ashley. So she turns 13 next month, and hopefully I have a connection. There we go. So it says she's female and she's 13. So it's off by about, I took this about a month ago, so it's off by about 2 months. So not bad. So the next thing that we've done, though, is a thing called CaptionBot. Now, CaptionBot is kind of like the next level of what you do with How Old. Caption Bot lets us take any image, and it will try and understand the image. So I'm going to start, of course, with the easy one, which is I took these pictures of goats in the Cascades about 2 months ago. Goats always look like they're posing. They have a funny look on their face. It's analyzing the image. Let's see what it says. I think it's a goat standing next to a forest. All right? Now, I want to underscore there's no human involved in that process. This is models that we've trained with billions of images telling them this is a goat. And I don't know whose job it was to mark goats and feed that into the system. I don't know. Maybe that will be my punishment if I screw up bad enough on this thing. Lance, you're going to take a lot of goat pictures. Let's try some other ones. So this is not sure why it's rendering like that. Uploading image. Okay, here we go. I think it's a person riding a surfboard on a body of water. That's pretty good. Let's try another one. Let's do something a little harder. I think it's a group of people posing in front of a crowd, and they seem smiley, smiley, not so smiley, 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 not so smiley. So I think the two guys in the back are the not so smiley. But there it's actually it's recognizing people in front of a crowd. So that's a pretty complicated picture. Now, just to kind of show you that I'm not making this up, I'm gonna do one. I'll show you one that it's not going to get quite perfect. And we'll go back to that picture of Ashley. Okay, so this says, I think it's a woman holding a donut shop and she seems happy. I don't know what holding a donut shop means. She's going to hold up the donut shop or what it is exactly. But I think it is pretty amazing that it's able to recognize pastries in the glass, in the counter behind her, and then deduce that that might be a donut shop or a pastry shop of some kind. So what we're seeing here, the reason I show this to you is it's like, okay, why am I doing this? It's all kind of cool. It's all fun. I want to know if somebody's in a donut shop or not. Well, there are tons of applications of image recognition that we see in business. Whether that might be looking for failures on cracks in rails on a train track, or looking for, I think one of the examples yesterday was, has a package arrived at my door? Any kind of image processing that you might imagine, object recognition that you can take out of that smart toys. Like there's all kinds of crazy scenarios that we see from this. We did a project with a conservancy that's responsible for tracking over 100 different kinds of species of giraffes in Africa. And they were manually taking pictures of the giraffes, and then they had people whose job it was to just sort through the giraffes and classify them. It turns out that if you can get a picture of the torso of a giraffe, it's kind of like a thumbprint. We were able to build a model that with 98% accuracy could identify the species of the giraffe just based on its torso. And so now they've been able to automate this system and basically bring the images in, flow them right into the model, and have them automatically categorized so they know exactly where each of the species is throughout the areas they're responsible for. All right, I'm going to go. So there's a lot of stuff there. I'm going to skip past the video. Have you guys all seen this video? Yeah, so I'll skip it, but that's pretty cool. The next thing that we're focused on is solutions. So it's really building templates out for, I talked about models. Models is great, but solutions are even better because then you have code plus models working. And so we're really trying to reduce the time to solution, reduce the time to insight. So these are the core areas that we're focused on for solutions. And we're also looking to partner on these. I don't think we'll cover every single one. So if you're interested in that, I'd love to talk to you. Let me show you an example. So starting this week, we've added Cortana Intelligence solutions to the Cortana Intelligence website. So if you go to cortanaintelligence.com, you can see these solutions. They give you details on architectures that you can use and explore for how to actually build out the solutions. We have some that actually will allow you to upload your own data and play with them. So you can connect your own data, and actually it will tell you the schema, and you can upload that and then see it. And if you want to deploy it, you can deploy it into your own subscription, and it will give you all the resources stitched together working with the application that you can then go modify for your use. Over time, we'll want to open this up in the Cortana Intelligence Gallery so that other people can contribute solutions as well. I think that'll be another area for community participation. Oh, did you guys see this yesterday? Who here saw Satya's keynote yesterday? Did you see the Lowe's demo? Yes, that was, what did you think of that? Was it pretty cool? That was my team. So what we said was, what if we took, and there's a whole session, I think at 4 o'clock today that Nino Bice is doing that's a deep dive behind that, so I'll just kind of touch on it briefly here. But we said, what if we took what you can do with the HoloLens, treat that as a device, and then put Cortana Intelligence behind that? That's really what led us to that system. And so we used, and some of this was, we didn't have time in the script with Satya to put it all in here, so I wanted to give a little bit more insight as to what we were doing. We built a deep neural network to understand the Pinterest images, to extract people's preferences, because we found that's a common, or Lowe's actually found, it's a common thing that people do when they're going to do a remodel, is they pin the images of what they want their kitchen or whatever room to look like. And so if we can actually extract the knowledge from those, we can match that against the Lowe's product catalog, and we could even match it against the customer's purchase history. And then we could say, based on what you've pinned, the images you've pinned as your dream kitchen, intersected with the Lowe's product catalog, we also took all of the web logs from the Lowe's website and fed those into our recommendation system. So we know not only the things that the customer would like, but we can match that with what other people on the website have transacted and what they like. So you can bring all that together and basically put the HoloLens on, and you see the kitchen that is the closest match Lowe's can do to your dream kitchen. So there's a lot going on there that we can do. Of course, you saw also we use the speech, some of the cognitive speech APIs and the text analytics APIs to extract topics and sentiment. And that lets us do things like take a view of a virtual kitchen like this, overlay heat maps so that we can see where you're focused, because the HoloLens knows where your eye is looking. We can match that with what you're saying, and you'll notice at the beginning, I think Jennifer, who was doing the demo, she was very careful to ask for permission to record up front, and then also to say this is anonymized data that we can look at to see this kind of trends. And we can look at the sentiment. So what did people like, what did they not like about that kitchen? We can also look at that over time. We can look at specific things, like I could click in on cabinet knobs and I could see what they said or didn't say about each item. And I can look at, if I'm Lowe's, and this is more of a Lowe's view, I can look over time what kinds of trends are happening in the boards that my customers are bringing in. And does that match my inventory? Maybe there are gaps in the way we're buying and what our customers prefer. And maybe that shapes the way that we actually order and the way that we think about how we stock our products. And this is an example. It's a real-world example for Lowe's. They're actually deployed, portions of this are already deployed in 2 of their stores, and they're going to roll out to more stores. But there are so many applications, whether that's, in this case, it was retail, anything in manufacturing. We can overlay the same kind of analytics and give a view on top of large machinery, show where failures happen, show how to repair them, things like that. So if you think about that augmented reality world powered by an advanced analytics engine, there's a lot we can do there. All right, and I'm just about out of time. We'll have a minute or 2 for questions. So next steps, check it out. I'd invite you to explore today. Go to CortanaIntelligence.com to check it out. I'll share, this deck is on the site, so go to the workshop to get trained if you're not familiar with it. And we also have a course in the Microsoft Learning Essentials that you can use to get up to speed on these pieces. Like I said, or like Bill said in the beginning, these changes these 3 trends are coming together to make incredible changes, and it's a blast. It's actually a lot of fun because of the diversity of the scenarios and the kinds of things people do is amazing. So I'd invite you help us with this and join in. And with that, I'll thank you and open up the time for any questions, and we'll hang out on the side here after. Feel free to come up and we can talk more if needed. Thanks.